Multi-AI retrieval augmented text generation can fail. Let's understand this on a quantum coherence level. So we have information that exists in a superposition. Welcome to a quantum analogon in AI. We will construct domain-specific mathematical spaces that make RAG coherent. We will collapse the wave function of integrated quantum system and try to understand here coherent subspaces and coherent spaces when we extend to multi-AI system. Because even in the classical case of vector databases, our vector structure become non-coherent subspaces for multi-AI agent-based system. So the question is, how do we design coherent multi-AI system? Well, an LLM as a dimensional manifold is more or less a complex function approximator in a semantic space without a metric. A vector database has a metric. So our non-trivial problem is now the mapping between two different types of mathematical spaces. We have possible solution, but you know what? Between our two spaces, I want to find a simple, beautiful solution. My solution is sentence transformer, generating the embedding to populate the vector database in the first place. So my system architecture has three elements: an expert system, a vector database, and one or multiple LLM system. And now the beauty is that the mapping here, my mapping strategy, is done by expert as the Rosetta Stone between the two spaces. I achieve semantic consistency, computational efficiency, and only have to watch out for the data drift. Therefore, if it's too trivial, think of an LLM as a quantum field, as a quantum state in a high-dimensional Hilbert space where we have a wave function on a natural language. Our vector database is more or less a repository of quantum states where we have measurement, and the moment we have measurements, we have Heisenberg's uncertainty principle. Now it becomes beautiful. If we increase the accuracy in one metric, like understanding the semantic correlation, we decrease the efficiency of retrieval. How can we decouple these systems? Now, with a diffeomorphism from topology, and this is again an S-Bert transformer. So if we create here semantically embedded vectors in a vector space, we create semantically coherent subspaces. And those subspaces are rather easy to construct. You have a spanning set, you have a projection operator that maps any vector in the vector space to the closest approximation of S, and you have a coherence measure for a degree of semantic coherence of the vector in this space. Now you commented that there is an incoherence performance of Autogen when integrating external databases, and now we understand why. So how should we build this? I have taken all your comments and integrated in 3 points: databases, system integration, and update time schedules. Databases: MySQL, Postgres, SQLite, and NoSQL. MongoDB, Redis, Apache Cassandra, or Neo4j, whatever you choose. It is more or less always the same: relational algebra, tables, SQL, ACID, business application. Vector databases, metric spaces, vectors, API-based nearest neighbor search algorithm that works nice in 2D, is easy in 3D, but what the hell defines the vector in 768 dimension? Well, of course, it's the training data set. And look at the vector spaces. They can be so beautiful here with DAL-E3. So, now that we know what it is, what systems should you integrate in your multiple AI agent system? I go with GPT-4 as my main intelligence and autoregressive system, and I have then a supervised fine-tuned LLM, a SQL database for numerical data. I do not have a vector database and I do not buy embeddings. I have an image archive, I have multiple expert system, encoder-only transformer systems, and I have a lakehouse architecture, data lake, delta lakes. Integrating new data, when to fine-tune. I have constantly an influx of new training data. That I have an expert system that I pre-train and fine-tune, and an LLM system that I continuously fine-tune to have a data validation. Every week I make a data validation. Look at archive computer science categories. I have more than 150 preprints per day. This is about 21,000 pages a week. I update my system. So I have weekly fine-tuning of my expert system, and without doing the same to my LLM, I will have de-coherence. Now imagine you have a stable vector store, absolute decoherence. For Ben, learn about optimization, information theory. Think about embedding, pre-trained embedding model, population of databases, the first vector generated. The embedding model, the indexing, and the query structure. Now, imagine you have trained your text corpus on mathematical text, and now you ask a medical sentence. What will happen? Nothing good. So, domain-specific models are a solution. I have a high semantic relevance and have an optimized performance and a contextual understanding that is really special for the specific domain. And with this method, I have new semantic data coherent. So my special system is a GPT-4 system as domain intelligence, 2 Mistral fine-tuned system on physics and AI, SQL and search engine, and 2 SBERT system for physics and AI. Plus, GPT-4 generates my agents, and I'm looking forward to the new OpenAI Python SDK, especially for API. Let's see us on OpenAI Developer Day. I do not use a vector store since this is a stable element that will not update regularly. So here you have it, how to design coherent multi-AI systems, and it would be great to have a feedback from you.